Exponentiation is an operation involving three numbers. The base b is the number being raised, the exponent n raises the base, and the a is the result of exponentiation. The logarithm is the inverse of exponentiation. It means that the logarithm of a number a to the base b is the exponent n to which b must be raised to produce a. It is pronounced b raised to the nth power is equal to a, or b to the nth is equal to a for exponentiation. And for the logarithm, it reads the logarithm base b of a is equal to n, or the logarithm of a base b is equal to n. Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I would like to show you the solution of several exercises on exponentiation and the logarithm with increasing difficulty as a preparation for exams. Let's begin with the properties of exponentiation. Property number 1, a raised to the mth power times a raised to the nth power is a raised to the power of m plus n. Second property, a raised to the mth power divided by a raised to the nth power is equal to a raised to the power of m minus n. Third property, a times b raised to the nth power is equal to a to the nth times b to the nth. Decide now, a divided by b to the nth power is equal to a to the nth divided by b to the nth. A to the mth power and the entire number raised to the power of n is equal to a raised to the power of m times n. Observe that this is different than this. This is addition and this is multiplication. And the last property that's going to help us solve the exercise is this. The nth root of a to the mth times b to the mth is equal to the nth root of a to the mth times the nth root of b to the mth. Now my friends, let's go to the exercises. Let's begin with the exercises. Exercise number 1, simplify this. 2 raised to the 5th power times 2 raised to the 6th power is equal to. What can we do to simplify this expression? We simply use the properties that we just saw. It becomes 2 raised to the power of 5 plus 6, and this is 2 raised to the 11th power, or if you prefer, 2 to the 11th. Let's go to exercise number 2. Calculate this. 3 raised to the 15th power divided by 3 raised to the 12th power. What can we do? We are going to apply the property. It is going to be 3 to the 15th, and we are going to put this number in the numerator. And how can we do this? We are going to proceed as follows. Times 3 raised to the power of negative 12. This is how we convert from the denominator to the numerator, like that. And observe that as we did here, it is going to be 3 raised to the power of 15 minus 12. And this is 3 cubed. And 3 cubed is 27. Okay, my friends, this is the solution of exercise 2. Let's go to exercise 3 now. What is the difference between this and this? Let's work on them separately to understand the difference. Working on this first, it is 5 raised to the 5th power plus 5 squared times 5 raised to the power of negative 1. We converted from the denominator to the numerator as we did here, and whenever we do this, we inverted the sign here. Observe that it was 12 here, it became negative 12, and here it is the power of 1, and it became the power of negative 1. Okay? And now we apply the distributive rule here, and the next step becomes 5 to the 5th times 5 raised to the power of negative 1 plus the distributive rule applies to the addition. 5 squared times 5 to the negative 1, and here 5 minus 1 is 4. 5 to the 4th plus 2 minus 1 is 1. Simply 5. And this is the solution of this. We have simplified this into this. Now let's work on this. 5 to the 5th times 5 squared divided by 5 is equal to 5 raised to the 5th power times 5 squared times 5 raised to negative 1. And we can apply this rule here that we used in the first exercise, and it's going to become 5 raised to the power of 5 plus 2 minus 1, and this is equal to 5 to the 6th power. Okay, my friends? Let's go to the fourth exercise now. Exercise number 4. Prove that 3 to the power of 0 is equal to 1. Let's go to the solution, my friend. We can prove that 3 raised to the power of 0 is equal to 1 if we make this assumption here. We're going to assume that 3 to the nth divided by 3 to the nth is equal to 1, of course, because we have a number here. 3 to the nth is going to result in a number. Okay, let's call this number A. But the same number is in the denominator. 3 to the nth is also equal to A. And A divided by A is equal to 1. And using exponentiation, we are studying exponentiation, we can say that 3 to the nth divided by 3 to the nth is also equal to 3 to the nth times 3 to the negative n. Okay, when we pass from the denominator to the numerator, we invert the sign, and then we finally find that it is 3 to 0. Okay, that's why 3 raised to the power of 0 is equal to 1. Alright, my friends, this is the conclusion. Every number, it can be 3, it can be any kind of number, every number b raised to the power of 0 is equal to 1. This is the conclusion that we get from this exercise. Let's go to exercise 5 now. evaluate 4 raised to the power of negative 3 raised to the power of negative 2. How do we solve this? You have to understand that these parentheses here mean that the entire number here is being raised to the power of negative 2. Okay? It is not only 3. It is 4 raised to the power of negative 3 that's being raised to the power of negative 2. Okay? So 4 to the minus 3 is being raised to negative 2. Okay? And in this sense, it is multiplication rather than addition. It is going to then be 4 raised to the power of negative 3 times negative 2. And then it results in 4 to the 6th power. Okay? You can go back to one of the properties that we studied in the beginning of this video to check why it is multiplication and not addition. Let's move on and go to exercise number 6. Exercise number 6 wants us to tell the difference between two expressions. What is the difference between two cubed raised to the 4th power and 2 cubed to the 4th? That's the question. Do you have any idea about the difference between this and this? Let's see, let's try to understand. Firstly, 2 cubed to the 4th, you observe that the parentheses say that the entire number inside of the parentheses is being raised to the 4th power. Okay? Then what we need to do is to do what we did here. We multiply. It is 2 raised to the power of 3 times 4, and this is equal to the 12th power. And how about the other? Do you have any idea? The reference textbook from which I took this said that it doesn't happen in nature, okay? But mathematicians like to distinguish this one from the other, and we have to understand this, how to distinguish one from the other. In this here, 2 cubed to the 4th, it is not the entire number like this that's being raised to the 4th power. It is only 3, okay? Then it is 2, 3 to the 4th is 81. Then it is 2 being raised to the power of 81. Different from this, okay? So this results in 2 to the 12th power, and this results in 2 raised to the power of 81. Alright, my friends, this is the culture that we get from exercise 6. Let's move on to exercise 7. Which two integers is the square root of 55 between. What we need to do is to find the closest numbers to 55 that have integer square roots, okay? So in such a way, 55, the square root of 55 is going to be between A and B. And what is the lowest number closest to 55 that has an integer square root? It is going to be 49. And the closest number to 55 greater than 55 that has an integer square root, it is 64. Consequently, the square root of 55 is between 7 and 8. Okay, my friends, this is exercise 7. Let's go to exercise 8. Exercise number 8, calculate this. And to solve, firstly, we have to understand that 81 is equal to 3 to the 4th. Then we are going to substitute 81 by 3 to the 4th. Consequently, 81 to negative 3 is equal to 3 to the 4th raised to the power of negative 3. And we are going to multiply them. 4 times negative 3, and then it is the power of negative 12. 3 raised to the power of negative 12. Okay? And how about the square root? No. The 4th root of 81 raised to the power of negative 3. We can convert it to 81 raised to the power of negative 3, and observe that the root is the same as raising the number by a 4th. Okay? The 4th root is similar to raising the number by a 4th. And in this way, we are going to convert it to 3 raised to the power of negative 12 raised to the power of a 4th. And this is equal to 3 raised to the power of negative 3. Negative 3. And 3 raised to the power of negative 3 is equal to 1 over 27. Okay? But observe that this root here is not in the numerator. It is in the denominator. Okay? Consequently, 1 over 27, we substitute this by this, and it equals 27. Then we know that this is equal to 27. Okay? And this is all for exercise 8. Let's go to exercise 9. exercise number 9 now. Evaluate this and the strategy that we are going to use to solve this exercise is to work on the 2's and the 3 separately. Okay, observe that 4 is 2 squared, and then if we convert it to 2, it becomes 2 squared raised to the power of 2/3 times 2 1/6 divided by 2 to the negative a half. And here this side 3 1/2, 3 raised to the power of 3/2 divided by 3 raised to the power of a half. Working on them separately, we find that it is 2 multiplying 4/3 times 2 1/6 times, to convert from the denominator to the numerator, what we do, we invert the sign. 2 raised to the power of a half times 3 raised to the power of 3/2 times 3 negative a half. Okay? What we need to do is to sum the exponents, then it becomes 2 4/3 plus 1/6 plus 1/2 times 3 3/2 minus 1/2. Okay? Taking the lowest common denominator, we find that it is ultimately 2 squared times 3. Okay? 3/2 minus 1/2 is simply 1. And this is equal to 12. And this is the solution of exercise 9. Let's go to exercise 10. Exercise number 10. Simplify this, the square root of 1440. What can we do to simplify this? We're going to use the prime factorization of 1440, and it is 2 to the 5th times 3 squared times 5. And we put this factorization in the root, and it becomes 2 to the 5th times 3 squared times 5, the square root of it. But remember that the square root is similar to raising a number to the power of a half. Then it is 2 5 times 3 squared times 5, a half. And simplifying further, we find that it is 2 raised to the power of 5/2 times 3 raised to the power of 2/2 times 5 raised to the power of a half. Okay? And in this way, we find that it is equal to 3. 2 divided by 2 is 1. 3 raised to the power of 1 is equal to 3 times, I'm going to split it apart here, this 2 here, and I find that it is 2 squared times 2 raised to the power of a half okay? Because 5 half is equal to 2 plus a half, okay? I simply split it apart. And times 5 raised to the power of a half. And combining these two here, we find that it is equal to 3 times 4 is 12. And the combination of these two here, using one of the properties that we saw in the beginning of the video, we find that it is the square root of 10, okay? And this is the solution of exercise 10. Let's go to exercise 11 now. Exercise 11. Simplify this. Simplify the cube root of 144 divided by 125. What can we do? We are going to factorize this, okay, into its prime numbers, the prime factorization of 144 and 125, and it becomes the cube root of 2 to the 4th times 3 squared divided by 5 cubed. Okay? But remembering that the cube root of a number is similar to raising this number by a third, okay? And therefore it becomes 2 to the 4th times 3 squared divided by 5 cubed, and it all raised to the power of a third. And we are going to multiply this by this. It becomes 4 thirds. We are going to multiply this by this. It becomes 2 thirds. And this by this becomes 3 thirds. And in this way, we find this. 2 4 thirds times 3 2 thirds divided by 5 3 thirds. And ultimately, if we follow the same procedure as we did here, we're going to find that it is 2 fifths times the cube root of 18. Okay, this is the solution of this exercise. And exercise number 12 is of the sort: what is the value of, what is the value of 8 raised to the power of 0.666 minus 9 raised to the power of 0.5. What is the value of this number? This is the question. And to solve it, we have to observe that this is equal to 2 thirds. Okay? If you divide 2 by 3, you're going to get this. And observe that 0.5 is obviously a half. Then the expression becomes the expression becomes 8 raised to the power of 2/3 minus 9 raised to the power of a half. Observe that 8 is 2 cubed. Okay, so it is 2 cubed, 2/3 minus, observe that 9 is 9 raised to the power of a half is the square root of 9. Okay? We multiply this to 3 times 2/3 is 2. And the square root of 9 is 3. Then it's going to be 4 minus 3, which is equal to 1, my friends. And this is the solution of exercise 12. Let's go to exercise 13. Exercise 13, if 2 raised to the power of x is equal to b, then in letter A, write 2 raised to the power of negative 2 plus 3x in terms of b, and in letter B, what is the numerical value of b equal to 10? Okay, my friends, this is exercise 13. Let's go to the solution. Observe that 2 raised to the power of negative 2 plus 3x is equal to 2 to the negative 2 times 2 raised to the power of 3x. Okay? And 2 raised to the power of negative 2 is equal to a fourth. And how about this term here? We're going to isolate. We are going to apply the following. 2 to the x, and it all raised to the power of 3, or if you prefer, it all cubed. And the exercise wanted us to use this 2 to the x equal to b, and we are going to substitute. It becomes a fourth of b cubed. And ultimately we find that it is b cubed divided by 4. This for letter A. Now for letter B, we want the result if b is equal to 10. Simply b cubed divided by 4 is going to be 10 cubed divided by 4, and we know that 10 cubed is 1,000, and 1,000 divided by 4 is 250. This is exercise 13. Let's go to exercise 14 now. Exercise 14 is this. If 6 to the 6th times 8 to the 8th power times 9 to the 9th is equal to 2 to the 8th power times 3 to the bth power, or to the power of b, what is the value of a minus b? This is the exercise. We are increasing the difficulty now. We need to find a minus b. Let's firstly convert the numbers here into powers of 2 and 3. Okay? So 6 is 2 times 3, isn't it? Then we're gonna have that it is 2 times 3 to the 6th power. And how about 8? 8 is 2 cubed, isn't it? Then 2 cubed to the 8th power. And how about 9? 9 is 3 squared. We substitute 9 by 3 squared to the 9th. And then we simply, in this part here, we know that it can be converted to 2 to the 6th times 3 to the 6th. And how about this? What can we do here? Observe that it is multiplication 3 times 8. 3 times 8 is 24. And how about here? 2 times 9 is 18. 2 raised to the power of 3 raised to the power of 18. And now it is not multiplication anymore like this. Here it was multiplication 3 times 8, 24. Now it is not multiplication anymore, it is addition. Then our number becomes 6 plus 24 is 30. And for the 3's, 6 plus 18 is 24. Okay? The exercise required us to equal this to this. Alright? And this is equal to this. 2 raised to the power of A times 3 raised to the power of B. And we know if this is equal to this, then A is equal to 30 and B is equal to 24. Could you see why? Then A minus B is equal to 30 minus 24. And this is equal to 6. Okay, my friends? Could you comprehend exercise 14? Let's go to exercise 15 now. Exercise number 15. Simplify this. Okay, my friends? How can we do this? The only technique that I can see is that we shall write all terms with respect to 2 raised to the power of 18. How? See that 2 raised to the power of 20 is equal to 2 times 2 times 2 raised to the power of 18. Okay? Alright? And 2 raised to the power of 19 is equal to 2 times 2 raised to the power of 18. If you can understand this, it is going to be easy for you to comprehend the next step. The next step is, in the place of this term, we put 4 times 2 raised to the power of 18 plus 2 times 2 raised to the power of 19 divided by 2 raised to the power of 18. What we need to do is to factor out 2 raised to the power of 18. That's what we're going to do. And this is going to be 2 raised to the power of 18 divided by 2 raised to the power of 18. And inside of the parentheses we have 4 plus 2 divided by 1, okay? Observe that we have not made a mistake. If I multiply this by this, we return to this and this. And if I multiply this by this, we return to this and this, okay? We have not yet made a mistake. It is right. And we simply cancel here. This divided by this is 1, and 4 plus 2 is 6, my friends. And this is the solution of exercise everything. How about exercise 16 now? Exercise 16 says, knowing that x plus 1 over x is equal to 4, knowing that this holds true, find the value of x squared plus 1 over x squared. This is what the exercise wants us to calculate, the value of this, knowing that this holds true. The technique that I can see, if maybe you can see another solution, but the solution that I can see is to raise both sides of this equation to the power of 2, or if you prefer, to square both sides, and it becomes x plus 1 over x squared is equal to 4 squared. Extending this, we find that it is x squared plus 2 times x times 1 over x plus 1 over x squared, and this has to be equal to 16. Okay? Frequently, we use x to represent times, but here, to not be confused, we're going to use the dot to represent times whenever you're using x for other purposes. And we can cancel this x with this x, and this becomes x squared plus 2 plus 1 over x squared is equal to 16. We pass this 2 to the other side, and we find that x squared plus 1 over x squared is equal to 14, and this is the solution of the exercise. This is the solution of exercise 16. Okay? And exercise 17 now. What is the integer solution of the equation? 2 times 5 raised to the power of 2x minus 5 raised to the power of x plus 1 plus 3 equal to 0. The exercise wants us to find the integer solution of this equation. There may be other solutions that are not integers, but the exercise wants us to find only the integer solution of the equation. And to solve the exponential equation, we are going to utilize an auxiliary variable, okay? Observe that the expression here can be converted to 2 times
5 to the x squared minus 5 to the x times 5 plus 3 equal to 0. And we're gonna do the following. We're gonna use that y is equal to 5 to the x. And we're going to substitute this here, and we find that the expression is therefore converted to 2 times y squared minus 5y plus 3 equal to 0. It becomes a quadratic equation, and the solution of the quadratic equation is very much known. Using Bhaskara, we find that y is equal to negative 5 plus minus the square root of negative 5 squared minus 4 times 2 times 3, and it all divided by 2 times 2. Okay, this is how the expression, we learn it frequently in high school, how to solve this equation here, the quadratic equation. And this has two solutions. Solution number 1 is 3/2, and solution number 2 is 1. Okay? And if we substitute, okay, we have to return to this because we don't want y, we want x in the original equation. If we substitute, 5 to the x has to be equal to 3.5, or 5 to the x has to be equal to 1. Observe that there is no integer. This is very important. There is no integer. If you put in the place of x, we find it returns 3/2. There is no integer solution to this equation here. And the only solution is going to be here. And we know that 5 to the x is equal to 5 raised to the power of 0. Okay, every number raised to the power of 0 is equal to 1, and therefore we find that x is equal to 0. And this is the only integer solution of this equation. Okay, my friends, let's go to the last exercise of exponentiation and jump to the logarithm. Now the last exercise of exponentiation, exercise 18, what is the solution set of the inequality 4 raised to the power of x plus 7 less than or equal to 16. The solution is this, my friends. Reducing both sides to the base 2, we get that it is 2 squared, because 4 is 2 squared, raised to the power of x plus 7 less than or equal to 2 to the 4th. Okay, 16 is 2 to the 4th. We are going to further simplify this, and it becomes 2 raised to the power of 2x plus 2 times 7 is 14 less than or equal to 2 to the 4th. And this holds true if and only if 2x plus 14 is less than or equal to 4. Okay? We pass 14 to the other side. And ultimately we find that x has to be less than or equal to -5. And then what is the solution set? The solution set is this. The upper boundary is -5. And we are going to have numbers here. -6, -7, -8, and so on. Okay? This is the solution set of our problem. Okay, my friends, and this is all for exponentiation. Let's talk about logarithms now. Let's begin the study of logarithm with some logarithmic identities. The first logarithmic identity that we are going to discuss is the logarithm of 1 in any base. The logarithm of 1 in any base is equal to 0. Why? You may ask me why the logarithm of 1 in any base is equal to 0. It's because any number raised to the power of 0 is equal to 1. Okay? That's why the logarithm of 1 in any base is equal to 0. And how about the logarithm of a number in its own base? It is equal to 1. For a raised to the power of 1 is simply a. Any number raised to the power of 1 is itself. The third identity is this. A raised to the power of logarithm of b base a. This is equal to b, okay? Why? Because we are raising a number by the logarithm of b in its base, and it is b. How about the next, this is very important, the next identity, the logarithm of bc base a. This property is very important. It helps a lot with exercises. This is equal to the logarithm of b base a plus the logarithm of c base a. This is the product. Similar to this is the logarithm of the division. Logarithm of b divided by c base a is equal to the logarithm of b base a minus the logarithm of c base a, okay? It is very important. These two here specifically help us a lot in solving exercises. And how about the power? The logarithm of b raised to the power of r base a is equal to r times the logarithm of b base a, okay? This is very important as well. And the last identity that we are going to use, that's going to help us a lot with the exercises, is the change of base. The change of base is this, the logarithm of b base a is equal to the logarithm b base c divided by the logarithm a base c. Okay? These properties, if you prefer, these identities will help us a lot understand and solve the exercises. Let's go to them. Let's go to the exercises. Exercise 19. What is the value of logarithm 256 base 2? And the solution consists of converting the number 256 to the power of 2, okay? 256 is equal to 2 to the 8th, okay? This is what we are going to do. And converting, it becomes the logarithm of 2 to the 8th power base 2. And use one of the properties that I just wrote on board, you're going to remember that we can pass this power multiplying 8 times the logarithm of 2 base 2 and resorting again to the identities that I wrote on the board. The logarithm of any number in its own base is equal to 1. Then it is simply equal to 8. Okay, my friends, this is all for exercise 9. A very simple one, just to get us started with logarithms. And now let's go and solve more difficult exercises. Exercise 20. If the logarithm of x base b is equal to negative 3 and if the logarithm of y base b is equal to 2, calculate the value of e, where e is equal to the logarithm base b of x squared divided by the fifth root of y. Okay? This is what we are going to do, and we are going to use the property of division. It is then the logarithm base b of x squared minus the logarithm base b of the fifth root of y. Okay? And knowing that we can pass this power multiplying, we find that it is equal to 2 times the logarithm of x base b minus, we can convert this, okay? Observe that the fifth root of y is equal to y raised to the power of a fifth. And passing the power multiplying, we find that it is 1/5 of the logarithm of y base b, okay? But the exercise says that the logarithm of x base b is equal to negative 3. Then we multiply 2 by negative 3. And how about the logarithm of y base b? The exercise said that it is equal to 2. Then it is 1/5, 2, and then it is equal. If we carry out, we find that it is equal to 32/5. Okay, my friends? And this is all for exercise 20. Let's go to exercise 21 now. 21. Exercise 21 says that if the logarithm of 2 is approximately equal to 0.3. Observe, I didn't mention it, but I am going to mention it now. Whenever the base is omitted, it means base 10, okay? So we say that the logarithm of 2 is equal to approximately 0.3, or if you prefer, the logarithm base 10 of 2 is approximately equal to 0.3. The exercise said this, and if the logarithm base 10 of 3 is approximately equal to 0.5, calculate the approximate value of the logarithm of 24, the logarithm of 0.06, and the logarithm of 8,100. Okay? Let's go to the solution. Observe that 24 is 8 times 3. Okay? 24 is 8 times 3, but 8 is 2 cubed. Then the logarithm of 24 is equal to the logarithm of 2 cubed times 3. Okay? This number here is equal to 24. We apply the rule of the product, and then we find that, and passing this power to this side, it becomes 3 times the logarithm base 10 of 2 plus the logarithm of 3. And we simply use the values. In the place of the logarithm of 2 we put 0.3, and in the place of logarithm 3 we put 0.5, and we find the value of approximately, it is approximately 1.4. Okay? If you don't have a calculator and you are participating in an exam, the exercise may give you approximate values, so you're going to be able to calculate. Otherwise, only with calculators you're going to be able to use logarithms. And how about this? The logarithm of 0.06. What can we do to calculate this? Okay, observe that 0.06 is equal to 6 times 10 to the minus 2. This number here is equal to 6 times 10 to the minus 2, or 6 times 10 raised to the power of negative 2. You choose the way you speak this. Some people speak 6 times 10 to the negative 2. Other people say 6 times 10 to the power of negative 2. And observe that 6 is equal to 2 times 3. Okay, we put it, the logarithm of 2 times 3 times 10 to the negative 2. And we multiply. It is a multiplication. It can be converted to the logarithm 2 plus the logarithm of 3 plus the logarithm of 10 to the negative 2. Okay? The logarithm of 2, the exercise said it is 0.3. The logarithm of 3, the exercise said it is 0.5. And using the property of the power, minus 2 times the logarithm of 10 base 10. The logarithm of 10 base 10 is simply 1. And then we find that the logarithm of 0.06 is approximately equal to negative 1.2. Okay, negative 1.2. And now the logarithm of 8,100. The logarithm of 8,100. How do we calculate this? Observe that 8,100 is equal to the logarithm of 81 times 100. Okay? If you multiply this, you get this number here. Observe that 81 is 3 to the 4th. And observe that 100 is 10 squared. Okay? We pass this here multiplying. It is 4 times the logarithm of 3 plus 2 times the logarithm of 10. Base 10 is simply 1. And then ultimately we find that this is approximately equal to 4. The logarithm of 8,100 is approximately equal to 4. And this is all for exercise 21. Let's go to exercise 22. Exercise number 22 now. If the logarithm base 10 of 2 is equal to a, and the logarithm base 10 of 3 is equal to b, express this in terms of a and b. This is the exercise, and let's go to the solution. The solution of this exercise consists of, firstly, understand that they are of different bases. This is base 10 and this is base 100. We have to convert this to base 10 before solving, and this is going to be our first step. Okay, the logarithm base 100 of the cube root of 4.5 is equal to the logarithm base 10 of the cube root of 4.5 divided by the logarithm base 10 of 100. Alright, 4.5 is equal to 9 divided by 2. We are going to use this, that logarithm of the cube root of 9 divided by 2 divided by the logarithm of 100. But 100 is 10 squared. We can use 10 squared here rather than 100. Okay? And observe also that the cube root is equal to raising a number by 1/3. It's the logarithm of 9/2 raised to the power of 1/3. And this, we can pass this number here. It's 2 times the logarithm of 10 base 10. Okay? We can pass this 1/3 to this side here. We're going to have that it is 1/3 times the logarithm of 9 divided by 2 base 10 divided by only 2, because the logarithm of 10 base 10 is 1. And ultimately we find that it is 1/3 times a half times the logarithm of 9 minus the logarithm of 2. Okay? But 9 is 3 squared. Then we find that it is 1/6 of 2 times the logarithm of 3 minus the logarithm of 2. Okay? And the logarithm of 3 is b, and the logarithm of 2 is a. Then we can confidently say that the solution of this exercise is 2b minus a. Okay, my friends? And this is all for exercise 22. Let's go to exercise 23 now. Exercise number 23 now. What is the domain of this function? Okay? To solve this exercise, we have to firstly understand that by definition, the logarithm a base b is equal to c, okay? The logarithm of a number a base b is equal to c. It means that b raised to the power of c is equal to a. Alright? This is the definition. By definition, the base of a logarithm has to be greater than 0 and not equal to 1. Okay? Observe that b has to be greater than 0 and not equal to 1. This is the condition, and this is the very definition. As a consequence, there is no number c that makes this true. B raised to the power of c less than or equal to 0. Okay? Thus, if this is impossible, a has to be greater than 0 and c is free. Okay? If we understand this, we are going to understand how to calculate the domain of that function. Applying this here, 5 minus 2x is a. 5 minus 2x has to be greater than 0. Thus, x has to be less than 2.5. And how about the base? X minus 2, the base, has to be greater than 0, 2, but additionally, the base must not be 1. Okay? Why not? Why not? If the base is 1, then there is a problem there. Because we can put any number here in the place of c and it is 1 all over to infinity. So to not make our logarithm get stuck or stall if you prefer, we have to impose this condition that x minus 2 has to be different from 1, not 0, different from 1. Okay? And in this sense, we find that the base has to be greater than 0, x has to be greater than 2, and x has to be different from 3. This is the condition, okay? This is the condition for this number here, and this is the condition for this number here, the base. Let's put them together. 2.5 here. X less than 2.5. X has to be greater than 2, but not equal to 3. Okay? And putting them together, this is the domain of the function. The domain D of the function is x belonging to the set of real numbers, provided that x is between 2 and 2.5. Okay, this is the domain of the function. This exercise is interesting. Okay, you may find such a thing in an exam. Let's go to exercise 24 now. Exercise 24, find an approximate value for 10 raised to the power of x equal to 440 if we can make the logarithm 2 approximately equal to 0.3. Okay, my friend, this is the condition of the exercise. Let's solve it. We are going to use the logarithm in such a way. The logarithm of 10 to the x equal to the logarithm of 440. And we are going to pass this power multiplying here, as the property tells us it is possible. Then we find that it is x times the logarithm of 10 equal to the logarithm of 440. And since 440 is equal to 2 squared times 10 times 11, okay, you can check it. We are going to have that the logarithm of 10 base 10 is 1. X is equal to the logarithm of 2 squared plus the logarithm of 10 plus the logarithm of 11. Okay? Because the logarithm of this is equal to this. If we apply the rule of addition, where the rule of product results in this addition here. The logarithm of 10, we know that is equal to 1. We are going to approximate the logarithm of 11 to the logarithm of 10. This is equal to 1, and this is approximately equal to 1. This is precisely equal to 1, it is approximately equal to 1. And then we find that x is equal to 2 times 0.3 plus 1, and this is equal to 2.6 approximately. Then if we can approximate the logarithm of 2 to 0.3 and the logarithm of 11 to the logarithm of 10, we find that x in this expression here is equal to 2.6, okay? And this is all for exercise 24. Let's go to exercise 25. Solve the equation. You're going to have an equation like this. The logarithm of x base 4 squared minus 3 times the logarithm of x base 4 is equal to 4. Okay? This is the equation. And again, we are going to make use of an auxiliary variable to help us calculate. Okay? We're going to do this. The logarithm of x base 4 is equal to y. This y is going to help us calculate there. If we put y in the place of the logarithm of x base 4, we find y squared minus 3y equal to 4. Or if you prefer, y squared minus 3y minus 4 equal to 0. This is a quadratic equation whose solution is pretty much known even to high school students. We're going to do the following. Y is equal to the negative of negative 3 plus minus the square root of negative 3 squared minus 4 times 1 times negative 4 squared divided by 2 times 1. And it's going to produce two solutions. y1 is equal to 4 and y2 is equal to negative 1. If we do not want this is not the solution that we're looking for, we have to return to this, okay? We are going to return and make the logarithm of x base 4 equal to 4 and the logarithm of x base 4 equal to negative 1. Okay? Here, 4 to the 4th is equal to x, where x is equal to 256. And here, x is equal to 4 raised to the power of negative 1, or 4 to the negative 1, which is equal to 0.25. Then the solution set of this equation here is equal to 0.25 and 256. Okay, my friends, this is the solution of exercise 25. Let's go to exercise 26. Exercise 26 now, my friends. How many digits does 2 to the power of 50 have? And to solve this question, we have to use this. The number of digits is equal to the logarithm base 10 of the number plus 1, okay? In which x is the number, this number here, and n is the number of digits the number has, okay? Consequently, n is equal to the logarithm of 2 raised to the power of 50 plus 1. And using the power, we find that it is 50 times the logarithm of 2 plus 1, okay? And the logarithm of 2 we can approximate to 0.3. 50 times 0.3 plus 1, and this is equal to 16. Okay? This number here has 16 digits. Okay, my friends? And this is all for exercise 26. Let's go to exercise 27, my friends. And exercise 27 is the last of this video. This video in which we debated exponentiation and logarithms. Exercise 27. If f of x is equal to 2 to the x and the g of x is equal to x plus 5, what is the value? If this is this and this is this, then what is the value of k in f of g of x equal to k times f of x, okay? The exercise is asking us this question: what is the value of k in this expression if this and this holds true? Okay, my friends, this is the exercise. Let's go to the solution. It is very simple, my friends. It is not difficult. It is very simple. Let's solve it. Okay? What does it mean? It is a composite function. It means that we have to substitute g in f. Okay? We are going to substitute g in f. Then f of g of x is equal to 2 raised to the power of x, but we are substituting g in x. So in the place of x we put x plus 5. Alright? This is what we have to do. It is simple. And this here, the exercise said that it is equal to k times f of x. Then it is equal to k times f of x. But f of x is 2 to the x. Okay? The exercise said that the substitution of this in this, okay, the composite function has to be equal to this, k times f of x. F of x is this. Alright? And in this way, we pass this dividing, we find that k is equal to 2 raised to the power of x plus 5 divided by 2 to the x. And this is equal to, separating here, 2 to the x times 2 to the 5th power divided by 2 to the x, which is simply 2 to the 5th. And 2 to the 5th is equal to 32. Okay, my friends? And ultimately we find that the value of k is equal to 32, my friends. And this is all for exercise 27 and all for this video covering the subjects of exponentiation and logarithms. Okay, my friends, this is all I wanted to show you. I am a teacher. If you want to have a private lesson with me, use my WhatsApp number, guys. Goodbye!